Hello everyone. Today we will solve a problem statically determinate portal frame. This is problem number 3. This is Mumbai University question paper problem uh, which was asked in December 2013 for 13 marks. So today we will solve this problem. So we know from the previous problem we know the steps. So the very first step here also is step number 1. Step number 1 reaction. First we need to find the reaction. Now here we have to define the reaction. This is hinge support, this is roller support. So at hinge support we know we have two reaction, VA, HA we are assuming in this way, and at roller support we have only one reaction. So now we need to find this reaction. To find VA we have to take moment about point D, which is equal to 0. So VA into 7, perpendicular distance is 7 and it is creating clockwise moment, positive, plus this 30 is there, 30 kilonewton. This is the line of action of 30 kilonewton and the perpendicular distance with respect to point D is 4 meter, and this is also creating clockwise moment, 30 into 4. Then you have this UDL. You have to see where the total load of the UDL is acting. Total load of the UDL is acting here. Total load of the UDL is 20 into this span, 4 meter. And this is acting at the center of the member BC. Center of the member BC means this is 4 meter, this will be 2 meter, and this is 3 meter. So distance from D is 5 meter. Okay, and this will create anti-clockwise movement. So minus the sign convention for anti-clockwise movement when we are following a direction left to right. 20 into 4, which is total load, into perpendicular distance with respect to point D is 5, equal to 0. You do not have any other forces than this. So VA you are getting which is equal to 40 kilonewton. To find VD we have to use the equations of equilibrium, summation of f of y equal to 0, VA minus 20 into 4, all the vertical force we have to consider, plus VD equal to 0. So VD comes to 40 kilonewton. Okay, and we also have to find this HA. In order to find this HA we have to use summation of f of x equal to 0. You take all the horizontal force into consideration. You have only one horizontal force and one horizontal reactions. So minus HA plus 30 equal to 0. HA equal to 30 kilonewton. Okay, so in this way we need to find the reactions offered by the support. Now you see we have the second step. Second step is to isolate the member and find the internal forces developed in the member, or else we need to draw AFD, SFD and BMD of each member. So the very first member is AB. Second step here. First member is AB. First we will draw the free body diagram of member AB. A, B. Free body diagram you have to show the load and the reactions on member AB. So we know we have here VA is 40 kilonewton, HA is 30 kilonewton. You also have load here 30 kilonewton. Okay. So we this is the free body diagram of member AB. Now we have to uh, make this member in equilibrium. In equilibrium means we know the reaction at point A, we know vertical reaction and horizontal reaction at point B, point A. In the same way, we need to find vertical and horizontal reaction at point B. Okay, so vertical reaction here, this is upward, this has to be downward in order to have equilibrium with respect to vertical direction. Now this member is in equilibrium with respect to vertical direction. Here 30 is going towards left and 30 is going towards right. So this is balanced with respect to horizontal direction. So if you want to find reaction with at point B, you will get 0 because already the balanced has occurred. Okay, so now you can find axial force diagram. You can draw axial force diagram. Axial force diagram is constant throughout the member here, and this is compression in nature. Okay, so for compression axial force we are indicating minus sign here, 40 kilonewton, 40 kilonewton. AFD axial force diagram for member AB. Shear force diagram, to take datum like this, above datum plus, below datum minus. Okay, left of A 0, right of A plus 30, left of B 0, right of B left of B 30, right of B 0, plus 30 kilonewton, 30 kilonewton. SFD of member AB. Stop the video recording. Okay, so this is shear force diagram of this member. Now we have to draw bending moment diagram. Bending moment diagram, this is the datum. Okay, bending moment at A is 0, we know, because it is hinge support. Bending moment at A is 0, and bending moment at B we have to find, because it is a rigid joint. Okay, so we will find bending moment at B. Bending moment at B, bending moment at A, bending moment at A is 0. Bending moment at B, A to B, left to right, 30 into 4, the perpendicular distance with respect to point B is 4. This is not coming into picture because we do not have any perpendicular distance. Okay, so 30 into 4 will come into picture, 30 into 4, and this is creating clockwise movement. Okay, so 30 into 4, you're getting here 30 into 4, 120 kilonewton meter. So we have done with the analysis of member AB. Now we need to go for the analysis of member BC. Okay, we shall resume with the analysis of member BC. Before analyzing or before going to the analysis of member BC, first we have to make this joint B in equilibrium condition. Okay, this is the joint B of member AB, and this is joint B of member BC. We have reaction here at joint B of member AB. We have to find reaction at B of member BC, so that the joint B is in equilibrium condition. It is in static condition. So this is going downward. Here the vertical reaction is going downward. Here it should be upward, 40 kilonewton. This is 0. this will be equal to 0. Okay, so I have done with the equilibrium of this joint B. Now we have to define, we have to make member BC in equilibrium condition. This is 0, 0 will be like this, 0 is not having any impact. Then also I am showing the direction in order to understand the balanced concept, the balance concept. 40 is going upward, and 20 into 4, 80 is going downward. So here 40 has to go upward. Okay, so now it is balanced. 40 is going upward, 80 is going upward, and 80 is going downward. So this is balanced with respect to vertical direction. Now you see, there is no axial force. Axial force is 0. AFD for member BC is 0. What about the shear force? You have to calculate. Shear force at left of B is 0. First draw the datum. Above datum, positive value of shear force. Below datum, negative value of shear force. Okay. Left of B 0. Right of B 40 kilonewton. Okay. Now when you are going to this point left of C, the entire UDL is going downward. Means 80 kilonewton load is going downward. This is 40 and 80 kilonewton load is going downward, means it will come to minus 40. Here it will be minus 40 plus minus 40 here. Then at right of C, 40 is going upward. So the shear force at this point, the right of C, it will be 0. Okay, this is 40 kilonewton, this is 40 kilonewton, and this is point of 0 shear. Point of 0 shear. Okay, so again we need to find bending moment at this point. We will define this point as point E. So both the triangles are similar, so this distance will be 2 meter. So this is at a distance 2 meter from B. Okay, I have not completed this. Okay, bending moment of member AB. Bending moment at A is 0, bending moment at B is 120 kilonewton meter. So the variation of the bending moment is straight line, positive at B 120 kilonewton meter. Okay, so we have done with some part of analysis of member BC. We are left with the analysis of bending moment for member BC. We know bending moment at B. We have calculated. Bending moment at B is 120 kilonewton meter. Okay, bending moment at B is 120 kilonewton meter. So that is positive. So take a clockwise moment of 120 kilonewton meter. Okay. Now we have to find this bending moment at point E, because at point E the shear force value is 0. We know from the basic that at a point of 0 shear you get maximum moment. So we are getting maximum moment at point E. We have to find that. Bending moment at B is, first draw the datum. Bending moment at B. Bending moment at B equal to 120 kilonewton meter. Bending moment at point E. Point E, you are going from B to E. You have to take all the forces and moment into consideration. Okay. So bending moment at E, 120. This 120 will come clockwise positive. Take positive value because you are following a direction left to right. Then this 40 will come, 40 into 2. 40 into 2. Okay, so this will create clockwise moment plus 40 into 2, and you have this UDL for this this much span. Okay, the total load of the UDL is acting at the center of this span. Okay, So 20 into 2 into 1, and this is creating anti-clockwise moment. So minus 20 into 2 into 1. So bending moment at E is bending moment at E is bending moment at E is 160 kilonewton meter. Okay. Now we have to find bending moment at point C. Bending moment at point C. So bending moment at point C. Bending moment at point C. C equal to, okay, this we are going from B to C, left to right. Okay, so 120 will come. 120 plus 120, 40 into 4. Okay, and this UDL will come. So 120 plus 40 into 4. 40 into 4, it is creating clockwise movement. This will come. Then this UDL, the span of the UDL is 4 meter. It is acting at the center of the span, at this point, center of the span. Okay, and the perpendicular distance with respect to point C is 2 meter, and this is creating anti-clockwise moment. Minus 20 into 4 into 2. So the bending moment at C you will get is 120 kilonewton meter. So you have to draw now bending moment diagram for member BC. Bending moment at B is 120. Bending moment at E is 160, and bending moment at C is again 120. The variation will be parabola because it is loaded with UDL. 120 kilonewton meter, 160 kilonewton meter, 120 kilonewton meter, B, E, C. Now last member CD. Member CD is inclined. Okay, C, D, the free body diagram of member CD. We have reaction here. VD is equal to 40 kilonewton. Okay, this angle is 53.13. You can calculate easily. This is 4 meter, this is 3 meter. So tan theta equal to 4 by 3, theta equal to tan inverse of 4 by 3. So you will get this theta value. Now see here, we need to understand, to draw axial force diagram, the forces should be along the member, and to draw shear force diagram, the forces should be perpendicular to the member. Okay, in order to draw axial force diagram, the forces should be along the member. In order to draw shear force diagram or to calculate shear force, the forces should be perpendicular to the member. Okay, so we do not have 40 kilonewton which is along the member or perpendicular to the member, so we need to resolve this along the member and perpendicular to the member. Okay, this angle is 53.13. This is 90 degree, 40 kilonewton. I can take little bit upward. Okay, it will be same. This angle will be 36.87. Now see here, the force is having inclination with respect to the member. This 40 kilonewton is inclined 36.86 with respect to the member. Okay, so the resolution of this force along the member will be cos component and perpendicular to the member will be sine component. Along the member will be like this, along the member, and perpendicular to the member. Okay, so the angle is with respect to the member. Along the member it will have a cos component, perpendicular to the member it will have sine component. Okay, so again I will draw here like this, along the member, perpendicular to the member, along the member 40 cos 36.87, perpendicular to the member 40 sine 36.87. okay, so along the member this you are getting 32 and this you are getting 24. So it will be like this. Again you can draw like this. This you are getting along the member 32, perpendicular to the member you are getting 24. This is point D and this is point C. Now we have to talk about equilibrium of member CD. This is going in this way. Here it should be in this way to have the to have the equilibrium with this direction. 32, 24 is going upward. Here 24 should be downward. Okay. Now I can draw the axial force diagram. Axial force diagram is compression in nature minus 32 axial force diagram for member CD. Okay, shear force diagram you can come from this C to D, left to right. Okay, this is datum for shear force. Above datum positive, below datum negative. CD you have to see in this way, CD, above datum, below datum. Left of C 0, right of C minus 24, left of D minus 24, right of D 0, minus 24 kilonewton. Okay, so this is shear force diagram for member CD. Now bending moment at D is 0 because it is a roller support. Okay, and we know bending moment at C we have calculated when we have analyzed the member BC. In that analysis we got bending moment at C, and we can write here also because the point is same. So we can draw bending moment diagram, datum for bending moment diagram. At point D the bending moment is 0, at point C the bending moment is 120 kilonewton meter, 120 kilonewton meter. C D bending moment diagram for member CD. Thank you for watching this video.